In our second example of a system of linear equations, we're looking at mixture of tickets here. A children's theater is selling tickets for their new production. 2 adults and 5 children's tickets total $46. 3 adults and 2 children's tickets total $36. How much does each type of ticket cost? So we're talking about 2 different types of tickets, right? We've got adults and children. So adult cost of adult tickets, and we've got cost of children's tickets. We don't know how much either of those are. That's what we're being asked to find. So any variable you want to choose to represent those, just make sure you label them. And then I'm going to read, not the first sentence because that doesn't say anything really, but the second sentence will give me my first equation then. So 2 adult tickets. Well, if 1 ticket costs X, then 2 tickets will cost 2X, right? And 5 children's tickets. So if 1 child's ticket is Y, then 5 will be 5 times that. And then it has the word total. Remember, total means that the sum is $46. So that's our first equation. Then the next sentence says 3 adult tickets. So 3 times X is the total for 3 tickets. And 2 children's tickets, so 2 times Y, total $36. So that gets us our system of linear equations. Then we have to choose a method to solve. We can graph, but that's, messy. So substitution or addition elimination. What would be a better choice here? It doesn't matter which one you choose, but these equations are already in the standard form, so why not do the addition elimination? So we can eliminate whichever variable we want. It doesn't really matter which one. Let's say I want to eliminate X. Okay, so I need the coefficients to be the same number, but opposite signs. So one of these equations has to be multiplied by a negative. The other will stay positive. So I need a least common multiple between 2 and 3. They don't share any factors, so that's going to be 6. I want this number to be 6. So that means I have to multiply a 3 to the 2 and a 2 to the 3. So in our first equation, we're going to distribute a negative 3 to each of those terms in the equation. So negative 3 times 2 is negative 6 times X. And negative 3 times 5 is negative 15 times Y. Don't forget the other side. And negative 3 times 46 is negative 138. Then let's do our second equation. We're going to be distributing the 2. So 2 times 3 is 6X. 2 times 2 is 4 times Y. And on the other side, 2 times 36 is 72. Now that we have the same number, opposite coefficient, we can go ahead and add these 2 equations together to eliminate the X variable additively here. So negative 15 plus 4, that's going to be a negative, no, not 9, 11Y when we subtract. And on the other side, when we add these, that's a difference of 66, and the bigger number is negative. So that means we only have Y in the equation. We're going to go ahead and solve for Y here with the multiplication property. That's going to get us just Y on the left side. And on the right side, that's a quotient of 6, and it's positive. So we think that children's tickets would cost $6, because that's what we found for Y. So now we need to go back to one of those equations. Doesn't matter which one. Preferably one that we had before we multiplied. So let's say we take this equation here. 2x plus 5y equals 46. Well, we think that y is 6. So when we put 6 in for y, let's solve this equation for x and see what we find for that variable. So 5 times 6 is 30. We need the addition property to opposite that term, get just 2x term on the left, and that difference is 16. So then we just need the multiplication property to get just x on the left side here, and that quotient is 8. So we believe that adult tickets would cost $8. Does that make sense? Let's check. In the first equation, or second sentence here, 2 adults. So 2 adult tickets would be 2 times 8, so $16 for 2 adults, plus 5 children's, so if they're $6 each, that's 30. Total $46. Yep. The second equation, or third sentence here, 3 adults, so 3 times 8, that would be 24 for the adults, plus 2 children's at $6 each. Total $36. Yep, that makes absolute sense here. So then we just need to answer the question, how much does each type of ticket cost? Well, $8 for adults, $6 for children.